Today we are going to talk about the last of our conic sections called a hyperbola. So a hyperbola is a set of fixed points in the plane where the difference of these distances from these two specific points called the foci is constant, meaning that, so the red line is the red curves are the actual graph of the hyperbola. Notice there's two of them, very similar to what we would see with a rational function where we have two. But we're taking distance from these 2 points to anywhere on these curves, and we're taking the difference of them, meaning bigger one minus the smaller one. No matter where I put a point on anywhere on these curves, I measure those distances. The differences of those points, differences of the distances to those points will always be the same value, okay? Now, as we go through and we look at this shape yields us two easy to use equations. Now, if you look at these, you'll notice that these look very, very similar to our equations for ellipses, except there's one key difference in these. The key difference is instead of adding these fractions, we're now subtracting them, okay? Instead of adding these things, we're now subtracting them. So one of these fractions becomes negative, okay? Notice that the x squared and the y squared switch positions on the top, because in this first one over here, this is where our x squared is the positive fraction. So let's write that in here so we don't forget about it as we work through this. So that means that this one here, the x is the positive fraction. Over here, the one with the y is the positive fraction. Now that's important because this can open in two ways. This graph can open up on the x-axis or it can open up on the y-axis. And the way that we tell the difference with that is depending on which one of these things is positive. If the x squared fraction is positive, we get a graph that looks like this. Our graph opens up on the x-axis. And that's important because you can see these points in here, these two sets of points that we're going to need to find called the foci and the vertices. The numbers that we'll find are going to be x values for these things, okay? This graph is also a little bit different because it has asymptotes, okay? Those asymptotes come from these a and b values underneath this. And we look at this one, this is b over a. Now, when we talk about this, this is an equation of a line, meaning this fraction b over a, this is a slope. So why is this one b over a? Well, if we look at this, it's b over a because the value of b is associated with the fraction that has y with it. The value of a is associated with the fraction that has x with it. Slope is always y over x. So the reason these asymptotes have a slope that is b over a here is because the number that we associated as b, it's paired up with the y, a is paired up with the x, okay? Only thing we have left to find is this value of c for the foci points, and that is found using normal Pythagorean theorem. I didn't try to get the triangle drawn in here to show you how that's calculated, but it is c squared is equal to a squared plus b squared, okay? Now, the second one where the y fraction is positive, it's going to look really similar to this, except it's going to open up and down. This graph opens up on the y-axis, okay? And that's important because you see our foci and our vertices all have y values associated with them with this a and c. C is still found the same way. And these points now here, this becomes a y value, this becomes a y value. And the asymptotes, though, the asymptotes are different. If you look, it's a over b this time because this number a is associated with the y, which goes on the top of our slope. B is associated with the x, which goes on the bottom of our slope. So our asymptotes here were going to be a over b. The way that we're going to tackle this to start is we're going to find these important points in these asymptotes. We won't spend a lot of time graphing it because we can graph this with technology, but we do want to find these important points. And the one that you'll likely be responsible for more often than not are these foci points, because those points aren't going to show up on a graph. We're going to have to calculate them, okay? So let's give this one a shot. So y squared over 16 minus x squared over 36 is equal to 1. So we're already equal to 1, so we're good to start. So first off, let's figure this out. Which way does this open? So this is going to open on which axis? Well, y squared fraction is positive. So if we look back, y squared fraction is positive, means that our graph is going to open up on the y. And I think this is important to label first before you get started, because when we go to find these values, we're going to find them the same way, whether it opens on the x or the y. It's just going to tell us whether those numbers should be x values or y values. So this opens on the y-axis. So what we know is we know that in general this looks like this. And that means that the vertices where it intercepts this axis are going to be 0, a, and 0, negative a. And then the focus points, which are going to fall out here, those are going to be c's, and they're going to be y values in this, so that we know how we're going to label these things when we find these points. So a squared was always the front, b squared was always the second. I always put the positive fraction first. Notice that a and b don't have anything to do with the actual size of the number this time like they did with ellipses. So let's go through and use that and find c. So if a squared is 16, that means a is 4. If b squared is 36, that means b is 6. Now to find our c, c squared is going to be a squared plus b squared. So we need to find the square root of this. So 16 plus 36 is 52. So c is equal to the square root of 52. So we got to make sure we can't do anything to this. Now I know 52 is divisible by 4. So that's going to be 2 root 13 when we go and we write this. So this is really 2 root 13 when we simplify it. So now we found our numbers for c, b, and a. So we can now go ahead and list our important parts of this. So the foci points. So we know they're going to start with 0 and they're going to be c. So they should be 0 plus or minus 2 root 13. Our vertices come from a. Those are going to have zeros here. So this is going to be 0 and a is 4 plus or minus 4. And the asymptotes, they're always going to be y equals plus or minus some fraction times x. And the fraction is what we need to fill in. Now the fraction is always going to be some combination of this a and b, depending, and we figure out which one goes on top by which one was associated with which variable. The 16 was associated with the y. That was our a. So that means this 4 goes on top. The 6 goes on the bottom this time, and we wouldn't leave that fraction like this. So this is plus or minus 2/3 x. So there's our asymptotes and our vertices and foci. And then if we were to sketch that graph, that's exactly what we would have when we'd look at it, okay? Let's try another one. So y squared minus x squared equals 4. Now, trouble with this one is we have a 4 out here. So that means we've got to divide everything by 4, because just like the other conics, just like ellipses, it needed to be equal to 1. So that's going to give me y squared over 4 minus x squared over 4 equals 1. So which way will this open on? So this opens on, well, y squared's positive again, so this is going to open on the y-axis. And that means, just like our last sketch, our graph part is actually going to be up here and down here. So that means that all of these things are going to have y values when we find them, okay? So our positive fraction always has a squared with it. Our negative fraction always has b squared. So let's see, a squared was 4. So that means a is 2. B squared is 4. So b is 2. C squared equals a squared plus b squared. So that's 4 plus 4. So c squared is going to equal the square root of 8, which is 4 times 2. So that's 2 root 2. So focus, vertices, and this one has asymptotes. So we know that these numbers are going to be y values because we're on the y-axis for this. So this is going to be 0, and focus is determined by the c. So it's going to be plus or minus 2 square root of 2. Vertices are determined by the a, and we know they're going to be y values because it opens on the y, plus or minus 2. And the asymptotes, y equals plus or minus whatever that fraction is times x. And we just need to fill in our fraction here. So our fraction is going to be the number underneath the y divided by the number underneath the x. Now remember, we need to take the square root of those, so it's these two. So it's 2 over 2, which would give us 1. So this is plus or minus 1 times x. So there's our asymptotes, our focus vertices. We go through, and this is what our graph would look like when we're done if we were to sketch it. So just like before, this is unaltered, untransformed. We'll talk about transformation just like we did when we dealt with the other two conic sections tomorrow. Just work on finding these important features right now, and don't worry too much about sketches of these because they're really hard to make accurate anyways. Really finding these features, especially this focus, is going to be our main goal. See you guys tomorrow. Let me know if you need help.